Okay, so if you have this guy from Nebis multinomial NB, and you remember we discussed about count vectorizer from sklearn dot preprocessing import count vectorizer. Oh, sorry, not preprocessing, it is feature extraction. Feature extraction dot text import count. Okay, count is equal to count vectorizer. Okay, so now let me create some text here. Text data. Let's see. I love India. Okay, India is best. Okay. Bhutan is beautiful. Okay, suppose I have this three text. Okay, now okay, so now what we want to do is we want to actually convert this into vectors. Okay, let's see how it is done. Okay, cd dot fit transform, right? Text data, right? We can see here it is converting into this sparse matrix, and if to see the content of it to area, right? You can see here like India is repeating 2 times to this column about it. Understood, right? It is actually converting into count dictionary. I mean count vectorizer. I mean each column means something. If you want to know what does each column mean, you can do this. Feature means what? So this is the first column is beautiful, Bhutan, India, and all that. Got it, right? This is the column names. So if you have data in this format, you can very easily use multinomial. Okay, NB here. Okay, so you can say these, and this is the input data. Understood, right? This is the input data. Okay, and I'm giving some tag, like I'm tagging it. If the line means about India, it will be 1. Okay, so I'm just creating a target here. Okay, so what is this target? 1,1,0. Understood, right? This is the class information that you have created. This guy is your text, this guy is your target, and if the line belongs to talks about India, it will be flagged as 1. If it does not, it is flagged as 0. Understood, right? This is the classification data. Very simple data we have created. No, this is first these 2 lines are talking about India, right? Okay, now multinomial NB is there, class parity is there. Okay, again class parity again. So we know that we want to give higher priority to 0.5, 0.25. Okay, it uh, oh, class prior. Okay, let me just check what it is. So here it is. Okay, then here I'm just talking about it first. Let me just switch. Okay, text data, and the outcome actually we will copy it over here. CV fit transform text data, feature data. Okay, then you do CV dot MNB dot fit feature. Fine. Understood, right? What happened? Just training it over here. This is the model creation happening. Actual data was what? Text data. Okay, and that is what multinomial net base is good at. Now after this, if you write MNB dot predict. Okay, if you convert, if you have some text, we can use this conversion and actually, so give me some new line which has the word India in it. Text, just give me some new line, anything. India, please. Just suppose have this text. Okay, this also had some India in it. Okay, okay, so now I'm just showing some simple example, India in it. So what will it do? We first need to use CF dot, what is that? Fit transform, right? We'll pass this text here so that we get a vector here. Okay, but we need is something like this. Okay, we get a vector here. So this will be the input to my MNB function, right? Okay, so you have MNB dot predict. Okay, pass the F here. Okay, there is some question. What is the okay? Why? What is the Y defined here? Y is the target actually. We need to create some text data and the corresponding target. So that is your Y here. So we have this predict F. What is it complaining here? Dimension mismatch. Okay, noise. What is the dimensional F? Oh, so MNB dot predict F dot. Oh, okay. M dot two. Oh, we should have used transform. Yeah. Just transform here. No, the same. No. See, yeah, but remember this model took input as a vector only. See, we remember earlier what we did transformation first. Okay, like we have this count vectorizer which was doing the transformation first. Okay, so what we have here is using fit transform. It is actually doing the transformation first. Okay, of the earlier data into things like this. Next, what it is doing, I mean, that is how it actually did the training part here. Now, if you do, okay, so let's do this. This is a new text, right? Till this point, it was clear, right? But we did transform the data, right? After transforming the data, okay, after transforming the previous data, we actually are
the first thing we did with
count vectorizer.
Second thing the count vectorizer, the transform data, and while is the target data, and the fitting into the name is.
So using the previous CV, we are actually transforming the new data as well. Yeah. Okay. So actually, that is one. You can see here. That is why it was complaining about shape, dimension, and all that. Understood, right? Yeah. So see this. What we did earlier. There are two steps how we did the entire thing. First one was you have text data. You use a count vectorizer to convert it into a vector. Then you use this, and remember, multinomial NIMBY, and as I mentioned earlier, is good with count vectors. Right. So and we used this count vectorizer to transform data. And all this algorithm, where the way it is trained, you can use it for prediction only that way. Okay. Okay. Yeah, you can do. We'll do that actually. Once you have converted this to this, right? That is what it was complaining dimension mismatch. Okay. So all you do is mnb dot predict f. Right. You can see it is identified in class one. Okay, so this I'm mentioning this awesome word first time, but still it is able to make sense out of it.
What is the use of this?
Text classification. Okay, so suppose you have, that's what we'll do. For example now. Okay, I'm using multinomial NB. Okay, after we discuss one more thing. Here also, as earlier, the configuration was priors and all that. Here it is class prior. Okay, the same thing. If you want, if you know that this class will have higher priority, you can configure it here.
Okay, bias the outcome.
You are biasing the outcome, absolutely. If you, based on your knowledge, you're biasing the outcome. Make sense here? Any doubts, guys?
Avantik, how many classes we have in this?
In these two classes, you can configure as many as you want.
So where we configure here only, right? Multinomial NB.
No. That will be configured when you're training the model, right? How many different values are there in Y? That will configure it.
So whatever we are giving in Y, that is our classes, or
right. Y is our target. So whatever unique. Okay, if you configure Y, so you can see these are your values 1 and 0. So how many classes are you configuring with it? With now is 2. Understood, right?
Okay, 2 classes. Yeah.
So that is how you configure. Multinomial NB is good for multiple classes.
Okay, yeah, got it.
Okay. Now the third, I will use it. We'll solve actually given a good. We'll give big text. We'll solve it. Multinomial NB will solve a text classification algorithm on Amazon data. Okay, it's a good problem. It's not Amazon data. First we'll do mail data, then we'll go for Amazon. Third problem I'm taking up now. Okay, so first one continuous data, next one discrete data or categorical data. Third one is, and remember the approach is different. In logistic regression, you're trying to predict a line. Here you are basing it in probability, isn't it? Okay, so I'll just show one more thing. Which Gaussian naive. That was target. All the things, all the algorithms are classification. There the input featured data was continuous. 1.2, 2.2 featured data. feature data. Huh? Yeah. 1000 rows. Those are continuous data, right? This thing was continuous data, right? If I see
What do you mean by continuous data?
continuous data is 1.2, 2.3, 2.7. No, I'm not talking about target. I'm talking about feature data. Like if I try to dump X here. Understood, right? Huh? If I try to do X here, X. Okay, you can see here. Make sense? Okay. So first was continuous, next was discrete or count data. Okay. The third one is your binary. Okay, this is the third type where the data is in binary, 0 and 1, like after doing one-hot encoder. Okay, for that we have Bernoulli's name base. Bernoulli, okay, Bernoulli's name base. As we discussed, it is for binary data. Data is in 1 and 0s, it works well. So before you apply Bernoulli's, I'm not talking about output. I'm talking about input. Here, all the data type output is classification. That will have 0, 1, and 2 discrete. All I'm telling about input is input here. Okay. NP dot random randint. Okay, this is your data. 3 columns with 1 and 0. This is your feature data. Okay. What is the target data? NP random dot randint. Okay, this is a target data. Target will be between 0, 1, and 2. Understood, right? Okay, target data and this data. Now, Bernoulli MB CLSF dot feature target. Okay, so we what we have is CLSF dot fit to map feature into target. So this algorithm is good for. Okay, so before you pass any data to this algorithm, you have to use one-hot encoder to convert it into vectors of 0 and 1. This part has to be clear. Okay, so now a few important points here to note, huh? Bernoulli's is also used for text classification. Okay, and Bernoulli is useful for small text, micro text like Twitter. Got it, right? That is where Bernoulli is, because each word you have to convert into vectors, and Bernoulli shows very good results with that. Is it clear? Okay, so the important point, the data should be in binary before you use it. Okay, see first if normal classification works or not, then you can make use of this guy. Bad knowledge. Okay, let's me show more things. Okay, now understood, right? How to use it, when to use it. So let's solve a problem. Problem solution. Okay, so this is a text data analysis. Text machine identifying which category a text belongs to. Identifying which category text belongs to. I'll use some Twitter data from sklearn and import sentiment. Okay, you can see here this is purely your Twitter data, huh? I'll check. Just one second. Yeah, guys, let's go for a 5 minutes break. Okay, I'll just come back. Okay. Okay, so let's see the data. I think in Twitter data is there in GitHub also, I guess. Just check, it is there. Okay.
I'm not seeing it, but when I go directly to
I added it recently also. might not sync with. Okay, so you can see a lot of columns here. All that matters to me is Twitter data. This is, so you can see positive, negative word here. Okay, and you can see some tweet here. Okay, so there are a lot of things we learn here. First is how to do cleanup of Twitter data. You can see a lot of @ Okay, right? So there are two columns that you're interested. One is text, one is, or if you want to solve a replacement problem, you can find retweet count. Based on text, you want to find how many retweets will happen. It's very useful data actually. Okay, it's, let me get some water. Okay. So these are the two columns that text and what was the column? Sentiment, right? Sentiment. Oops. What else? Oh, I didn't give two brackets on text. Okay, so these are the two columns of our interest. I don't need any other columns as well. Just overriding the Twitter data. Okay. I have to do a lot of text cleanup now. First thing, I have to remove all the. So I'll use a little bit of regex here. Okay, to remove all the @ a lot of people hashtag. I don't want to use hashtag RT, right? Because if you see the text, there are a lot of junk information which I don't want to use. For me, it is useless. Let's assume. Okay, you can see here a lot of these words are not useful for me. This word text may be useful. Hashtag is not useful for me. I want to remove them. Okay, so that is the next phase. Text data cleanup. Okay, so let's do this. So we have import RE, regular expression. Okay, then we want to remove. Okay, I'm just testing few things. RE dot substitute all RT by nothing. And what is the text? ABC RT. Understood, right? What will happen? It will replace all RT by nothing in this text. Okay, now I might not write a lot of them because we might have to actually have a That's what I'll do now. Okay. So F, just pass the text with T. Okay. Then RE dot, this is your final RE dot substitute. RE dot substitute RT. What all other things you want to remove? You want to remove all the word which is after at the rate, right? Okay, and let's test that also. Should always test it, or else become A at the rate. How was it written? I forgot. It's, okay, at the rate like this, right? At the rate slash W. Few of them as an example. Okay, at the rate slash W plus the rate. So R, okay, it will remove only that. Oh, I was wondering what happened. That's correct. Yeah. It will remove only after that. So I'll write this at the rate slash W plus. Okay, I just have to be a little cautious when writing this. Okay. What all things you want to remove? You want to remove colon also, right? Okay, so what you can do plus colon. It will remove that. Then at the rate followed by any text. No, not at the rate. Maybe you want to just remove at the rate, then some hash. These two things. The information might not be accurate. We're using a lot of junk information. Right. So what you're doing here, you're substituting anything which is RT by space, by nothing. This one, anything which starts with at the rate and slash W means small a to Z, capital A to Z. Okay. And alphanumeric 0 to 9. Okay. And underscore, I think. How do you learn all these things, right? I'll tell you a very, this is one page I have been, using for any ages now. Okay. It's Google regex. This, no, not this. Yeah, developers regulars, this page. Tag this page. Okay. So that is where you see a lot of quick cheats actually. So that's what. And last thing I won't want to do is dot substitute. Hashtag at the rate So this is the function. So what will I have to do? Twitter data dot text dot map f. Okay, it has converted all the lines here. And you might have to do a lot of things here. Okay, so I'm just keeping it short. Sorry. Oh no. Yeah, got it, right? Okay, so we have this thing now. Okay, now you want to see some distributions and all that. You can do this by sentiment. Let's grab it to show you the distribution here. Okay, so you have, this is your negative, this is your neutral, this is your positive. This is the distribution here. Understood, right? This is showing you the distribution. Showing you some distribution. Right. Okay, these are the target. This is the input data. Okay, group by, and you don't need all of the information. You can do a simply size here. Okay, this is giving you negative sentiments and more. Strange thing, right? Twitter has more negative sentiments. Okay, so let's see now. What we want to do is we want to actually create. I mean, we have done some data cleanup over here using this. Right now, we want to create a pipeline which will convert this data into count vectorizer maybe. Right. So for that, from sklearn dot pipeline import pipeline. Okay. Cleaning of the data. And whenever you're doing the sentiment analysis or rating analysis, that always remove the middle element. Like neutral is not much giving much information. Right. So delete that rows. Okay. Okay. Because anyway you intend to find out positive or negative. When you're training the model, right, you want to find positive sentiment or negative sentiment. There's nothing, I mean, you can do that, of course. I mean, you can continue with this. Or let's continue with this, not a problem. Generally, but it is a common practice to delete neutral. Okay. To reduce to get the sense out of it. I mean, you want either negative or positive, so we can make it very clear. Okay, so let's continue with this, not a problem. Okay, but and we can use sklearn from and data frame mapper. Like this column, negative, positive, this one you have to use your label encoder, right? And the first one you have to use count vectorizer. Mapper is equal to data frame mapper. What is the first column? Sentiment. What are you doing here? From sklearn dot preprocessing import label encoder from count vectorizer we anyway have, right? Sentiment. convert. Let us convert. Label encoder. This column. Then in count vectorizer mention the remember stop words English. Okay. Okay. This is your mapper. Now I really want to test it out.
Why we have not used label encoder?
See here, it is actually capable of converting it into vector. Okay. So what is on the fit transform? What will be the output? This will be your the first column. If you notice here, is your target. Rest of the column is your feature, right? So I need to break down it into target and feature, isn't it now? Then do the okay. Yeah, no need to break down here. I'm just keeping it here. I'll anyway connect this to your pipeline, right?
First column is our target. Target is usually sentiment field in the target. So we already converted that. The sentiment is the target. That is correct. Text is our feature.
Right.
So when we convert it,
the first column is your sentiment. This data, if you see the first column, this sentiment. How do you get the first column? This is the first column. This is sentiment. How do you get one column onwards, one column? Oh, sorry. Just give me like this. 0, 1 onwards. Understood, right? Okay. Now, okay. Now, what you have to do? You have to have a in this. Let's create a pipeline. In this, this is the data frame mapper, and then you will have a transformer. Okay. Or you can do like this also. Like from a multinomial name base, we anyway have it, right? Just okay, multinomial name base. Okay, just short cell, reducing some code writing here. Fit, right? Fit, and what are you passing here? That data colon comma 1 colon, isn't it? Colon comma 1 colon is forgot, just not good, right? I mean, after this part, you can do that, or okay, and no need to split actually. Okay, we'll pass some text, it will tell you the positive text. That direction. First column. Okay, this is the first step. So now let's. I mean, there are multiple ways by which you can write it. I'm just writing in a different way. This is your training feature data. I'll write something after that. Let's see if it is showing a positive sentiment or negative sentiment. Oh yeah, it's completed. Okay, let's see.
Without using method also we can.
Yeah. Okay. So I mean, yeah, I'm just doing it in one shot now. Okay, so you can create a pipeline also here, and you can connect it to this guy. Got it, right? So after that, MNB, the mapper is there, and in mapper you have okay, so this is first element and this is second element. This is common vectorizer, right? Dot trans. I mean, just okay. I'll write it in another style also. Transform. Right. So it is creating into vector. It's I'm writing there. Got it right? Where actually how you get it? Why did I in features I got okay? This is the access, right? My stuff. Now if I do, you can write it in a much more higher level as well. I'll come to that. Got to predict. It belongs to sentiment 0. What is sentiment 0? How do you know? Okay, I just need to receive a delivery. Just give me 1 minute.
Okay. तो फ्यूचर वन मतलब हो गया ये काउंट तो अब क्या हो रहा है फिर ट्रांसफॉर्म करके अलग से कुछ टेक्स्ट जैसे आई लव गुड्स वो वगैरह वो कन्वर्ट किया है काउंट लिटरेचर अब मान लो आपको किसी लेवल एनकोडर में चेंज करना है First question is call difference.
Yeah, so that's what we see now. Okay, now we want to see which class is it, which, okay, but you can do the same way, right? I mean, I think you can see now deeper details into this, right? Features. See what I did. First one was this, right? I need first guy 0. I got this guy. I need 0 over, right? I mean, I want to get here classes. See, this is 0 class is negative. Okay, then neutral, then positive. So, oh yeah, it is actually identifying it as negative. That's what it is telling you here, right? 0 is negative. Yeah, so it is actually for some it is negative. Okay. This is stuff. This see predominantly identify negative. You know why this is happening? If you see the data, this is too much of negative sentiments over here. Right? It is too much of negative sentiment over it. It's becoming heavily classified. So what you have to do for this, remember? Exactly. In your need base, you have to you can try many things. Apart from that, what is the need base algorithm? Yeah. What you can do is classes imbalance was there. Classes prior. 0.7, comma 0.3.
There are 3 classes.
Oh. Yeah, that is very true. 5, 3.2. Yeah, let's see if it is able to balance it out, if it's able to deal with this stuff. If not, we have other techniques. See, now it handled better, right? It got this right positive. Now it is handling it better. This was a good example to show it.
We are telling based on the data like segregation, we are telling it to give data that are more this kind of
so the algorithm is now aware.
By seeing the data,
see, when you're training the model, right? It starts with no biased information. It assumes that everything is ideal. Okay, with this parameter, what you're telling there, you'll get less data with positive classes. right? And that is where you want this priority. You remember last time we spoke about imbalanced classes. I didn't talk about it. Okay. Oh, no, I was in that impression. Okay. So what happens over there? The output classes are little imbalanced here, right? More data is of negative. Okay. You see that when you're training the model, right? You have to train the model with all possibilities equally, right? But this is not what is real situation. So when you have situations like this, when data is pretty much imbalanced, right? You have to make use of these variables. Does it make sense? Right after they see all I changed is this priority, and all of a sudden things started going good. This is bad stuff. Let's try this. See, it became more active, more absolute here. Yeah. Understood, right? What happened here? I'll give one more example. I actually, till this class before I was wondering what I used to try this Amazon data, but this is actually reactive. This is repeated data analysis. Okay, and here few things we did. We saw at a very low level how do you debug and understand various things. If you want to use this transformer, we are using this transformer. I'm not using pipeline in this case. Okay, now I'll show an example with pipeline quickly. Is it clear so far? Text analysis of mail data. Okay, from sklearn, the inbuilt data sets. I'll not do much cleanup here. We'll just directly sklearn data sets import. Fetch 20 news groups. Search this. So no, it was multinomial only. Okay, but we saw raw data coming into picture. We did sentiment analysis using multiple nominal, right? Okay, I'll show here using some pipeline. Okay, remember this will take little time. Right. They could have given less classes. It takes always. Yeah, the 20 groups in the data set. So this directory I'm fetching first time, so it will take. Okay, so I'll use a transformer. Okay, but this part was clear, right? Why did I do mapper.features 0, 1? How did I get there? I mean, I started with that. Okay, as a features, I mean, to do everything in one shot. All the inbuilt. Mapper object has inbuilt variable features. So see, there are a few things that we have to do here. Yeah, mapper here. So we have this label encoder to be done here and the count vectorizer. We could have done separately also. Okay, then added this count vectorizer. I mean, added this mapper one to a count vectorizer. Okay, maybe. Okay, to your pipeline, right? Count vectorizer is your pipeline, and the output of this would be in a vector, which would be input in the runtime process. Okay, so what you mapper and okay, so this is one way that I done. It's a lot of text data you can see here. 20 news groups are there. Understood, right? What happened in mapper one? There were one transformer which was transforming this positive, negative, neutral label encoder. The other guy was your count vectorizer. You can use TF-IDF also.
You already used 2 columns.
Right. I gave since my this class was weaker. See, what I did was if zeroth was negative, right? There are a lot of negative stuffs. Yeah, that's what. Yeah, so I gave here that a lot of negative classes are there. This is how you handle imbalanced classes. Okay, neutral I gave little more. I could have given little less. Which one? This one. So if we write automatically, it will. This is one of the default parameters.
The feature one.
Then what? So when you do features, I wanted the transformer, right? Count vectorize a transformer. See here. Okay, I want to use this guy one. If I do, I cannot execute this actually here now. So mapper dot. Okay, if I do mapper dot features, it was showing me sentiment as one tuple and count vectorize as another, right? I wanted to use this guy inside one. This is 0, this is 1. Inside this one, this is 0, this is 1. Tuple inside tuple. I mean tuple inside list. That's why I wanted to do that. Okay. Oh man, why is this taking so much? Actually, this is another directory where I generally don't write machine learning code. Why it is taking a lot of time, else it is already downloaded. No, this is a quite good example. I'll run another PowerShell in my other directory.
I download it.
Okay. No, I will restart. Okay. No, I'm running in another.
last week's
Yeah, I think the next time will not record.
the call got disconnected, right?
It was not recorded.
I think call got disconnected.
Okay, that I didn't start recording. I think what was the second half we discussed last time? Mostly around second part. After logistic regression, I think
one was there.
grid search, huh?
No, nothing was there.
Okay, so from SQL learn dot datasets import
This should be.
the tab not recorded. Okay, so we have this, and the data is equal to fetch 20 use groups. Yeah, so once it is downloaded, it will happen really fast. Okay, now what you are doing, if you see data.target names, okay, you'll see all the possible targets. See, these 20 type of classes are there. So I don't want to deal with all these classes and get a pretty confused answer. So I'll fix 4 categories and deal with that only. Categories. Okay. First is I need Ethereum. This is target name. These are 20. That's a 20 classes of mails are there. These are 1980s MIT's mail content. Okay. So and then give. Okay. Then you give some. Right. Say I have only these 4. Okay, only these 4 classes I have. I want to now actually just doing it. I want to get subset of this data. So you have APIs to make it really easy. Okay, you do this. 20 train is fetch 20, subset is train, and you are mentioning only these categories here. This will get to subset of train data. 20 train. Oh shit. So you just do this. Okay. Data. Understood? This is the first data. This is the first email. You can see here email subject. Okay, and if you want to know the target, do this. It will give you target 2. That means 1, 2. It is Christian content. Understood, right? Okay, let's see the data. Actually, I didn't notice it. See, is it related to Christian or what? I mean, this is categories religion Christian, right? Does it has to do anything with that? Huh? I mean, no. So based on the content, is it? No, not target. Okay, I'm not able to figure it out. Okay. Hey, data one is of target 0. Let's see data 1. It has to do something with religion. First stage atheism, right? See, not religious, sexual preferences, right? This data is about religion, atheism, and all that. Okay, this is the known target. You can see the amount of text here. Should organization be wall, blah blah blah. It is a this is the train data. I mean, this is the data which is already there. Got it, right? Okay. This is you can see here the content. Not religious. Okay, and what is the target information here? Target is 0. That means this data is actually mapped to atheism. Understood the training model? Yeah.
So when target is to find out
which type of mail is. Once you train with this data, okay, target data, what happened? Or this is you are getting, see, if you don't give it, it will take you all the data. It is too much of information. It cannot do too much. So just quickly want to do something. So I'm just using data with these 4 classes only. Okay. And I'll get subset of training data. So if you want, you can do subset is equal to test also to get the testing data. They're inbuilt APIs. Okay. So this is 20. This is okay. So, understood, right? Okay. So if you want to know how many data are there, you can do this len. Okay, it is 2258. There are total 2,258 data set. Now let's create a pipeline and we'll use all our techniques to do count vectorizer and multinomial NV to do the.
I can also write. I can write mail and I can write this.
Yeah. We'll do that. Okay, that means we'll write our own text. It will tell you what is this text about. We will do that. Okay. Now from sklearn dot pipeline import pipeline. Okay, from sklearn dot preprocessing import feature extraction dot text import count vectorizer from sklearn dot namebase import multinomial NV. Okay, then you have multinomial NV. MNV is equal to, anyway, I'll create a pipeline now. Pipeline. I'm not doing any data cleanup. Okay, so you'll have your pipeline. So what is the first thing here? First thing is your count vectorizer, right? And what is the column name on which you want to do count vectorizer? Oh, I don't have to write. So count vectorizer, right? Stop words is equal to English, right? This is the first thing that will happen in the pipeline. What is the next thing? Multinomial NV. We didn't do any distribution now, right? We didn't check. Let's do it like this only now. If you know the order, we should always give it, huh? Remember that. Right. I'm writing something wrong in the sentence. Oh yeah, I should give some names to that. Okay. In make pipeline, you don't need arguments, but here you need. Okay, so this is your pipeline. Now what you want to do? Dot fit. Right. You want to pass 20 train data. Okay, and let the training be finished. Okay, training is finished. Now you can directly do prediction using it. Okay, I love code. Class 3. What is my class 3? Not necessary, it will show it like this. Okay, I'll tell you it. You should not tease. I have done this mistake one more time. Okay, so how you should check it is always like this. What is this? What is this? What is this? 20 data. Okay, because that is the order in which you give. That doesn't mean it will be there. Okay, 20 data, target, names. This is the order. Achha. This is the order. 0, 1. Sorry, 0. 1, 2, 3. Christian. See? Okay, you give anything. You tell me. You give me any text. I'll tell you. Any text of these 4 categories. Hope you are fine. Hope is there, right? It has to become in 0. Hope among these 4, hope is something that will be in Christian religion as such. Tell me something about medicine. Are you fine? Is your health fine? Is it fine? It came into. But remember, the training is on very limited data. The more training you do, if you use Amazon food data and all that, it will actually do this classification. Give any sentence. Is your health fine? And like for example, I am not selling this. And we remember we are yet to do much more things. Oh. Right, understood. Okay, still this is 5 lines of code that we have written, not beyond that. Right, you can add a lot of functionalities here, you can make it really rich. Okay. Yeah, so that's all for today.
How is the targeting? Targeting. So we can add more targeting. So maybe that really something like how many data plans were there? 2000. 2000, right? So can we do it like take let's say these 4 categories only, split the data into test and train, and then import it, and then based on the outcome predict it and then compare the
you can use scope function, all it will work here. Yeah. So what you can do is we have this en20.
This is how we can tell how accurate our model is.
Yeah, 20 test is equal to, just copy this line. Okay, we can give it
and data from there.
20 tests. Okay. So, so now what you can do is pipe.score. Okay. 20 test dot data. 20 test dot target. It's around 94%. Right. So you're actually using the data here to test. Score is accuracy. This is the new data, right? I remember I haven't trained this data. This is the new data, test data. How confident accuracy? How confident this algorithm will work with 94% accuracy?
What it does is, we have records. We split into 70 and 30. Using those 70 records, we trained our model and then we trained our model, and then using those 30, we gave 30 features, not the target value, Gaussian value. And that value we are comparing with the actual results and trying to see how accurate our result is. That is the score.
Okay, the key points of prior thing classes. Remember that score, all the things that we did multinomial NB will be using a lot with text data. Okay, understood this, Nepis? I'll upload all the code now.
So, for the statistics, when is needed? I mean, when we should have it?
So you should know those things. I'm already telling it wherever other things are required. Okay, so but there is 3 to 4 hours of statistics class that we plan with every data science course. Okay, it will be notified. I mean, few of the batch and few of the people in this batch has attended it.
So that will show you in the last class.
Not before that only. See, what I do is, we should stop recording now.